This video is on section 4.2, standard form of a quadratic function. So you need to recall vertex form of a quadratic function, which is what you have learned earlier. So that is going to be y equals a times the quantity x minus h quantity squared plus k. So that is vertex form for a quadratic function. So we're going to end up working this section with standard form of a quadratic function. And standard form is that f of x equals ax squared plus bx plus c. Notice that is in function notation. This is where a does not equal 0, because if a did equal 0, you would have a function that would equal bx plus c, and that would be linear. So in order for it to be a quadratic, you have to have that degree of 2. Now, we're going to use this standard form, so standard form of this quadratic function, and it can give us little nuggets of information. For example, we can use it to help us find the vertex and the axis of symmetry. Once we have the vertex and the axis of symmetry, we can do a little a graph, a little sketch of that graph, just to give us an idea of what that function will graphically look like. All right, so this information, unlike the vertex form, is hidden. So in vertex form, you can pull out your h and your k. You can pull out your vertex. You can find your axis of symmetry, because the axis of symmetry is that vertical line that goes through the vertex. So in standard form, that information is hidden. So we have these properties here. Few things. First one, the graph is a parabola. That parabola is either going to open up or it's going to open down. We can look at this a value. So when we have this y equals ax squared plus bx plus c, the a value tells you if it opens up or down. So if the a value is positive, in other words, it's greater than 0, the parabola is going to open up. So it's going to look a little something like that. If the a value is negative, it's going to open down. A little something like that. And that makes sense because that negative indicates a reflection over your x-axis. So if your parent function, y equals x squared, opens up, well, then if we reflect that, then it's going to open down. So that makes sense. The axis of symmetry, that x equals h. Okay, so let me write that out here. Axis of symmetry. And we abbreviate that as like the AOS. So the axis of symmetry is x equals h. That's what we had before. Well, in this case, in standard form, you have ax squared plus bx plus c. I don't see an h there. So the formula that you're going to use is x equals negative b over 2a. That will give us our axis of symmetry. Now, the x-coordinate of our vertex, so if we have our vertex, that x-coordinate is h, and the y-coordinate is k. So in other words, if I know that h is negative b over 2a, remember that the axis of symmetry, h, is going to be the same as that x-coordinate for the vertex, which is h. So I can substitute in that negative b over 2a for the vertex coordinate. Now, in order to find this k, you're going to plug in that negative b over 2a into the function. And whatever you get, that is this f of negative b over 2a right here. That means the same thing as you're going to plug in negative b over 2a into that function. Now, if we have the axis of symmetry and we have a vertex, I really need one more point, because really it doesn't give me, a more precise graph. So the point that we are going to use is this y-intercept. To find the y-intercept, that value is c. Here's why. If I have ax squared plus bx plus c, and I'm substituting in 0 to find that y-intercept, I get y equals c. So that means when I plug in the x value at 0, the y value is c. That's the y-intercept. So the nice thing is with standard form is you can get that y-intercept right from the equation because it's the constant. Okay, so right here, that gives us our y-intercept. So let's take a look at an example. So I'm going to, let me get some graph paper here, because that will be beneficial. And for this example, I want you to graph y equals x squared plus 2x plus 3. Okay. Well, if I want you to graph this, there's a few things that I need in order to graph. I need the vertex. I need the axis of symmetry. I need the y-intercept. And then I'm going to have to reflect the y-intercept over the axis of symmetry to give me that more precise graph. So let's find out the things that we need. Well, I need the vertex. Well, I need the axis of symmetry. To be honest, I'm probably going to find that axis of symmetry first. So it is x equals negative b over 2a. Well, let's identify your a, b, and your c. Your a is the coefficient of the x squared, 1. The b is the coefficient of the x, 2, and c is the constant, 3. So x equals negative b over 2a. Well, that's negative 2 over 2 or negative 1. So the axis of symmetry is x equals negative 1. I'm going to use that to find the vertex. I know the vertex is negative b over 2a, and then I've got to substitute in to find k. So the vertex is negative 1 something. I've got to find that something. You're going to substitute x equals negative 1 into the equation. So y equals negative 1 squared plus 2 times negative 1 plus 3. So negative 1 squared, well, that gives you a positive, and 2 times negative 1 is negative 2. And if I add 3, let's see, that gives me 4 minus 2, so that is 2. So my vertex is the point negative 1, 2. Okay. Let's see, I found the axis of symmetry first. I found the vertex. Let's find that y-intercept. The y-intercept is 0, c. So what is c? c is 3. The y-intercept is 0, 3. Now, let's go ahead and plot what we have. And then we'll talk about that last reflection point. So I have an axis of symmetry at negative 1. I will make it dashed. And a lot of times I will mark it axis of symmetry. X equals negative 1. So my vertex is negative 1, 2. Notice your vertex is going to lie on that axis of symmetry. I'm going to put a little v beside that so that I know it is the vertex. So let's plot the y-intercept, 0, 3. So I can go ahead and draw half of that parabola. I know it opens up. It opens up because the a is positive. It is 1. Now, I need the other side of this parabola. I'm going to reflect this point. So I'm going to do this reflection point in red. This reflection point, remember the distance from the pre-image to that reflection line has to be the same on the other side. So the reflection point is the point, let's see, -2, 3. And now I can go ahead and draw the other half of my parabola. And that's how you're going to graph y equals x squared plus 2x plus 3 using standard form and these little handy-dandy equations. Let's do one more example. I want you to graph y equals 2x squared plus 10x plus 7. Okay, so let's think about all the things that we need. We need the axis of symmetry. I need the vertex. I need my y-intercept, and I need the reflection point. All right, that's what I need. All right, let's find that axis of symmetry. Axis of symmetry is x equals h, which is -b over 2a. Well, let's see. A is the coefficient of x squared, it's 2. B is the coefficient of x, that's 10. And c is your constant, 7. So I have -10 over 2 times a, which is 2. Let's see, that's -10 fourths. Simplify that, that's -5 halves. And for those that don't like fractions, that's -2.5. So now, I am going to find my vertex. My vertex is going to lie on that axis of symmetry. It's going to have the same x value, so -2.5. To find the y value of that vertex, I'm going to substitute -2.5 into that function. So y equals 2 times -2.5 squared plus 10 times -2.5 plus 7. All right, so let's see, -2.5 squared, then multiplied by 2 gives me 12.5. -2.5 times 10 gives me a -25. And then I have a plus 7. So let's see, what do I get for my y value? That's -5.5. So my vertex, -2.5, -5.5. Now, the y-intercept. The y-intercept is 0c. So that gives me 0.7. So I'm going to go ahead and graph that. And usually when I graph that, that kind of assists me in finding the axis of symmetry. Reflection point. All right, so here is my graph. I'm going to put in that axis of symmetry. It is at -2.5. So I'm going to make it a dashed line. So axis of symmetry, x equals -2.5. So then I've got -2.5, -5.5. And I'll put a little v beside that. Now I know it opens up because my a value is positive. I have a y-intercept at 0.7. So I can draw half of my parabola. So next point, reflection point. The reflection point, let's see, it's 1, 2.5 away. Here's my reflection point. I can go ahead, I should probably write that down, what the reflection point is. So reflection point. Let's see, that would be at -5, 7. And now I can go ahead and draw the other half of my parabola. All right, so guys, that's how you're going to use your standard form of a quadratic function and graph it.